Hey guys, welcome back. We're almost done with this tutorial or this mini lesson on how to answer each of the questions regarding system of equations in your portfolio. So when you see your question 5 on the portfolio, you're going to see a graph. There's going to be two equations on that graph, y equals negative x plus 2, y equals x plus 4, and you're going to be asked to do three different things. So this is what the graph looks like on your portfolio. And here's what the graph will look like in our practice question. As you could see, the numbers are different, so they will not be the same graph. The graphs are different. Now, the directions for this graph state that you need to plot a point that is a solution to one equation but not the other. Label the point A. If you remember back to question 4, the solution found for both equations was where the lines intersected, or where the two lines crossed each other. So I want you to keep that in mind when thinking about A, because A says that you can only plot a solution to one equation, but not the other. So I want you to look at the graph and look at these two lines. Each of these lines is an equation. So I want you to see this line right here as equation 1, and this line here as equation 2. So when you graph a point that is a solution to one equation but not the other, and you can either label it A. I color coordinate your dots. So if you put the black dot somewhere, I'm going to know that's A. And if you put the blue point somewhere, I know that's B. And you put the red point somewhere, I'm going to know that's C. And depending on your teacher, they'll tell you how to label them. For my class, I want you guys to use this color system. So let's work with A, and we're going to figure out where on this graph can we plot this point in a location that is a solution to only one of the equations. Now, I told you to look at these two lines and say that this is one equation, this line, and this line right here is a different equation. So when you plot a point that is only a solution to one of the equations, you have a few options. You could put this point somewhere that's on one line. You could put this somewhere that's not on any line, or you could put this somewhere even that's on both lines. So read these questions carefully. If you have an equation and you want to plot a point that is only a solution to one of those equations, you should plot the point somewhere on this line, that does not touch the other line. What I mean is this. So if I plot this point here, right? And it's on this one line, or this one equation. This point is a solution for this equation because it falls somewhere on the line. To be a solution to an equation, you must be somewhere on the line, meaning if you plotted this point, that would also be okay. Or if you plotted it here. Hell, you could even plot it here. And if you just don't like that location, you could plot it here. The reasons why all these work is because any location on either of these two lines would be a solution to those equations. But you can't put it here. This would be a solution for one equation, this one going this way, but it would also be a solution for this equation. So what you need to do is keep this black dot, or A, somewhere on just one of the equations. And you could save and close that. It's plotted. It's black, so it's A. Now, B, or the blue dot, says plot a point that is a solution to both equations and label it point B. It's blue. It's labeled. So let us now graph it. So before I said that to graph a point that is a solution to one equation, we need to graph it on one of the lines. So when you're graphing a point that is a solution to both equations, you need to graph or put this point in a place that is on both of the lines. So if you put it here, you ask yourself, is this a solution to both of these lines or both of these equations? If it is on both lines, then the answer is yes. But this is only on one of these lines, so it is only a solution to one of the equations. So I'm going to take this blue dot and find the place where it is on both lines. Let's see, is it there? Well, it's technically touching two lines, but I need it to be on the equation line. So that's not a point that I could put. What about here? Is that on both equations? Well, it's on this equation, but this equation it's still not a solution for. So I'm going to take this dot now and put it here. Now, is this a solution to this equation, the one that my cursor is following? It is because it's on the line. So let's look about the other line. Is this blue dot now a solution to this equation that my cursor is following? The answer is yes, because for a coordinate to be a solution to multiple equations or in a system of equations, it needs to be at a point where the lines are touching, crossing, or intersecting. And this would be the solution for this system of equations. Kind of like the last video where we figured out the solution and it's where the lines crossed. This point represents that crossing or that solution. Save and close. Lastly, C asks us to plot a point that is a solution to neither equation. That means we need to plot a point that does not fall on either of these two lines. So if these two are my equations, I cannot have this red dot anywhere on the line. So if I plotted my point there, that is incorrect because that would indicate a solution. So to plot my point in a place that is not a solution to either of these equations, I need to put it somewhere that is not on the line. Right there is not on the line. Right there. Whoa, don't want to do that. Right there would be a solution. I'm sorry, would not be a solution because it is not on the lines. So anywhere on this graph that is not on either of the two lines, you will be able to plot a point that does not equal, or sorry, that is not a solution to these two equations. So the only thing you need to do for this question is you need to plot the points. Again, the black point or point A is on a location that only solves or is only a solution for one of the equations, one of the lines. The blue dot represents a point that is a solution to both of the equations at the same time, where they cross. It's a solution for the system of equations. And the red dot, or C, represents a point that is not a solution to either of those. So what I'm going to do now is I'm going to bring these points back out for you guys to practice on your own. And then we'll go right into the next video. So again, if you have any questions, you could ask your teachers. You can write on my YouTube comments, and I'll get back to you. And I hope this helped. Joanne Finnemore commented on Flavio Gambino's post. Hmm?